For the second period elements, the correct increasing order of first ionization enthalpy is here 4 options given, which is the correct answer. Now see students, what is meant by first ionization enthalpy? What is ionization enthalpy? The amount of energy is required to remove the electron from the outermost shell of an atom. That means the amount of energy, how much energy is required to remove the first electron from the outermost shell of an atom, that is called first ionization enthalpy, students. Okay, so left to right, what is happening in the case of second period elements, the question. Now see here, in periods left to right, atomic size decreases. That means big to small. In the case of bigger size atoms, in bigger size atom, what is happening, students? Nuclear attractions are less on the valence electrons. But in the case of smaller size atoms, the nuclear attractions are more on the valence electrons. So that's why here we can easily remove the electron from the outermost shell of an atom in the case of bigger size atoms. So that's why ionization energy in this case, in case of bigger size atoms, students, in case of bigger size atoms, ionization energy is less. But in the case of smaller size atoms, students, ionization energy is more. That means ionization energy from left to right increases, correct? Ionization energy increases, students. Okay, ionization energy increases from left to right. So here these are the ionization energy values, students. But here seen beryllium and boron. If you see these two elements, beryllium is showing the more ionization energy value than boron. And nitrogen and oxygen, these two elements, you see, nitrogen is showing the more ionization energy value than oxygen. Okay now, but actually from left to right, at ionization energy value should be increased. But here what happened? Beryllium is showing the more ionization energy value than boron. Why it is happening, students? Here nitrogen is showing the more ionization energy than oxygen. Why it is happening like this? Because beryllium atomic number, see here, beryllium atomic number 4, 1s2 2s2. That means this is electronic configuration. This is the 2s is the valence shell electronic configuration. In 2s, how many electrons are there? 2 electrons are there. That means it is completely filled electronic configuration. And next, nitrogen atomic number is 7. That what is electronic configuration? 1s2 2s2 2p3. This is the valence shell electronic configuration. 2s, 2 electrons. In 2p, how many electrons? 3 electrons are there. That means it is having half filled electronic configuration. Half filled and completely filled. Half filled and completely filled electronic configurations are more stable, correct? It is completely filled electronic configuration, and this is half filled electronic configuration. Half filled electronic configuration, these two are stable, students. Are you clear? It is stable. So that's why in the case of stable electronic configuration, students, those elements, okay, they are not ready to lose electrons, students. That means those electrons are valence electrons are strongly bounded by the nucleus. That means more energy is required to remove the valence electron. Are you clear? So that's why ionization energy is required more. Clear this one? So that's why beryllium is showing the more ionization energy value than boron, because what is the reason? It is having the completely filled electronic configuration, and nitrogen is showing the half filled electronic configuration. Half filled p orbitals are more stable. So that's why nitrogen is showing the more it is showing the more ionization energy value. Clear? So option C is the correct answer. Clear, students? Thank you, students.